All right, let's look at the homework 8, problem number 18. All right, so we're trying to sketch the graph of f of x equals quantity 6 minus 3x times e to the x. All right, so let's do the first part. Let's see, we're talking about domain, right? So since there is no square root or even root or fraction, so in this case, all real numbers would be the domain. So here, check the answer. All right, we got that. How about the next? All right, intercepts. Let's find x-intercepts and the y-intercepts. All right, so in order to find the y-intercept is usually easier. And all you have to do is we can set x equals 0. All right, so we have f of 0 is going to be equal to plugging 0, so 6 minus 0, so it's going to be 6 times e to the 0 is 1, so it's going to be 6. Right? So y-intercept is 6. Right? X-intercept, if you want to find the x-intercept, you need to set y equal to 0, which is the function. So we set 6 minus 3x e to the x equal to 0. Right? And we know that the exponential function is always positive, so this guy is never 0. Right? So the only way we can do is we can make this guy equal to 0. So let's solve that for x. Add 3x. You get the 6 equals 3x. And we can just divide through by 3 to get the 2 is equal to x. So x equals 2 is the x-intercept. All right, so let's type it in. All right, so let's say x equals 2 is the x-intercept and the y equals 6 is the y-intercept. So check the answer. All right, we got that. All right, next one. We are looking for horizontal asymptote and a vertical asymptote. All right. So when you look at the vertical asymptote, we want to see where this guy might blow up or blow down. All right. In this case, there's no place where it blows up or blow down. So there's no vertical asymptote. And as x approaches positive infinity, you can see that e to the x goes to infinity, and this guy goes to negative infinity. So it's the whole thing is going to go to negative infinity. So there's no horizontal asymptote. And if let's see, e to the x goes to negative infinity, then this guy goes to 0, and then we actually have to consider that one. All right, so if you take the limit of this function, so you have 6 minus 3x, and then as x approaches infinity, right, then, e to the x here, right, then negative infinity, right, I'm going to write it this way, so it's a limit as x approaches infinity, right. Then I'm going to put the 6 minus 3x on top, and then I'm going to put the e to the negative x on the bottom, right? And this goes to negative infinity, right? So if you do that, then you can see that the negative 3 times negative infinity is positive infinity, and adding 6 is going to be still positive infinity. This guy approaches positive infinity, right? And the same thing, e to the negative infinity, so e to the positive infinity goes to positive infinity. All right, so you can use the L'Hopital's rule. So L'Hopital's rule here. We can just take the derivative of the top, which is negative 3, and take the derivative of the bottom, which is negative e to the negative x, as x approaches negative infinity. All right. So you can see that the denominator here, right, e to the negative, so this is going to go to negative infinity, right? All right, negative 3 divided by negative infinity is going to approach 0 because you're dividing by a really, really big number, all right, which means that there is actually a horizontal asymptote, which is y equals this limit value 0, right? So let's so there's no vertical asymptote. Let's see. Horizontal asymptote is y equals 0. Not that one. Horizontal y equals 0. So D is the right answer. All right. Let's check the answer. All right, we got that. All right, next one is we're talking about increasing, decreasing behavior. So we have to look at the derivative. All right, so let's find the derivative first. F prime of x is equal to, all right, so we have two things multiplied together. So we take the derivative of first guy, you get the -3, times the second guy is e to the x, and plus, right, first guy is 6 minus 3x, and second guy is derivative of e to the x is, luckily, it's just the same thing, right? Then if you simplify that, you're going to get, let's see, e to the x is in common, right? You have, let's say, -3, and so plus 6, so it's going to be 3 and minus 3x, right? All right, so this is the derivative, and we set that equal to 0 to find the critical number. All right, so you can see that, let's see, this set that equal to 0, x equals 1. So x equals 1 is a critical number. All right, then we can do a number line. So we're going to do an increasing, decreasing check. So put the 1 critical number there. All right, then we're going to look at the sign. All right, so any number smaller than 1, I'll try x equals, say, let's see, I'm going to use it. I'm going to try x equals 0. All right, after 1, we can try x equals 2. All right, so let's see if it's positive or negative. All right, so if you plug in 0 here, 3 minus 0, e to the 0 is positive, so this is going to be positive here. All right, if you plug in 2, 3 minus 3 times 2 is negative times positive, so it's going to be negative, right? So which means that the original function here is increasing before 1 and decreasing after 1, right? So let's type it in, right? So it's increasing before 1 and decreasing after 1. Actually, this is going to be the right answer. All right, so let's check the answer. All right, got that. All right, next one. All right, so we want to see local maximum or local minimum. So let's look at the shape here. All right, know that you have an increasing shape. So increasing shape turns into decreasing shape. So you can see that you're looking at the top of the hill. So here at x equals 1, you're going to have a local maximum, right? So let's do that. So local maximum at 1. So here, there's a local maximum at 1, right? Check the answer. All right, we got that. All right, then we have to look at the second derivative. So we're looking at the concavity. All right, so let's look at that. All right, we have to find the second derivative. All right, so take the derivative once again. All right, derivative of the first guy is again -3, and times the second guy is e to the x, plus you have 3 minus 3x times derivative of the second guy is e to the x. All right, if you pull out the e to the x, what's left is -3 and actually +3 cancel out, so you can cancel those. All right, so you're just going to get, or maybe I should do that. So you're just going to get the -3x. All right, if you set that equal to 0, you can see that x equals 0 is where the second derivative becomes 0. All right, so if you do a number line again, right, I should be able to draw a straight line a little bit better. All right, here 0 here. All right, then we look at the second derivative, and we're going to look at any number less than 0. So I'll try -1. Bigger than 0, I'll try +1. All right, so if you put -1, so -3 times -1 is going to be positive, so you're going to have a positive sign here. If x equal 1, so negative 3 times 1 is negative, so it's going to be negative there. All right, so which means that the original function is going to have, hold on a sec. All right, so original function is going to have a concave upward shape here and a concave downward shape after 1. All right, so let's check the answer. All right, concave upward on from up to 0, and concave downward from there. So it's D is the answer. All right, check the answer. All right, we got that. All right, there is an inflection point. All right, so you can see that the concavity changes at 0. Then there is an inflection point at 0. So check the answer. We got that. And the last one. So we have to find the correct picture. All right, so let's look at the increasing, decreasing. Remember that the graph should be starting out increasing after 1 decreasing. So which picture would do that? All right, so A is not increasing in the beginning. B is increasing, decreasing. B is promising, and the C is promising, and the D. So it's going to be B and C. Right, let's look at the concavity here. Right, actually, let's see, concavity. All right, and they start out the concave up, and after that, concave down. All right, so it's going to be a tough one to do. All right, looks like I have to make it look a little bit bigger here. Let's see if I can get that to work. All right. So it looks like it's a concave up to 0. After that, concave down shape. So this is promising here. And how about this one? All right. Oh, it's actually doing the same thing. All right. So another thing we have to look at was y-intercept. Remember that the y-intercept was 6. All right. So let's see if this is 6. All right. This actually doesn't go through 6. All right, this one goes through 6, so C is the correct one. All right, so check the answer. All right, we got that. All right, that's it. I hope that this was clear.